Hi everyone, welcome to Agnes Tech Zone. Previously, I explained the basics of CPU scheduling. This video will focus on solving an example problem. Consider the following set of processes with the length of the CPU burst time given in milliseconds. Process P1, P2, P3. Arrival time for the processes 0, 1 and 2. Burst time 5, 3, 1. Priority of the process 2, 1, 3. Normally the question format like this. For each of the following scheduling algorithms, first come first serve, shortest job first, shortest job remaining time first, priority preemptive, priority non-preemptive and round robin scheduling with quantum value 4. First question, draw a Gantt chart to show how these processes would be scheduled. Give the turnaround time of each process. Give the waiting time of each process. Give the average turnaround time and waiting time of all the processes. And finally, which of these scheduling algorithms give the smallest average waiting time. Before solving the problem, we must know the formulas for turnaround time and waiting time. Turnaround time is the total time taken from process submission to completion. The formula for finding turnaround time is equal to completion time minus arrival time. Next, waiting time. It is the total time a process spends waiting in the ready queue. Formula to find waiting time is equal to turnaround time minus burst time or execution time of the process. First come first served scheduling. To find the turnaround time and waiting time, we first draw the Gantt chart for that all processes. In the problem, they given the process arrival time and burst time. So we draw the table from the given data. Additionally, we include the columns completion time, turnaround time and waiting time. So first we draw the Gantt chart for first come first serve scheduling. Here the processes arrive in order. So first process P1 executed with a burst time 5. Then arrival time 1, process P2 executed. So the burst time of P2 is 3. So 5 plus 3 is equal to 8. At arrival time 2, process P3 executed with the burst time 1. So 8 plus 1, 9 milliseconds. So P3 completed its execution in 9 milliseconds. Now we calculate the turnaround time and waiting time. So the completion time of P1 process, look at the right side, 5. Completion time of P2, 8. Completion time of P3 is equal to 9. Now we find the turnaround time. So turnaround time is equal to completion time minus arrival time. So 5 minus 0 is equal to 5. 8 minus 1 equal to 7. Completion time of P3, 9 minus 2 is equal to 7. If the arrival time is not given, you just take arrival time is equal to 0. Now to find waiting time, the formula turnaround time minus burst time. So 5 minus 5 is equal to 0. 7 minus 3 is equal to 4. 7 minus 1 equal to 6. So based on that, we calculate the average turnaround time and average waiting time. Average turnaround time means summation of all process turnaround time divided by number of processes. So 5 plus 7 plus 7 divided by 3, the value is 6.33. And average waiting time the summation of all process waiting time divided by number of processes. Next one is shortest job first scheduling. It is the non-preemptive scheduling. We already know non-preemptive scheduling not given any priority to the other process. This is the Gantt chart for shortest job first. So here also we write the data for process arrival time and burst time. In shortest job first, it takes the minimum execution time or burst time value. But here the arrival time given. So at the arrival time 0, P1 process executed. It don't give any priority, so that it executed up to 5 milliseconds. At the time of 5 milliseconds, all the processes are arrived. So here we consider the minimum execution time or burst time. So P3 is the minimum burst time. So already 5 plus burst time of P3, 1 is added. So P3 completed its execution in 6 milliseconds. Next, P2 executed. So 6 plus 3 is equal to 9. Now we fill this completion time column. The completion time of P1 is equal to 5. Completion time of P2 is equal to 9. Completion time of P3 is equal to 6. Now turnaround time. Turnaround time is equal to completion time minus arrival time. So 5 minus 0 equal to 5. 9 minus 1 is equal to 8. 6 minus 2 is equal to 4. Waiting time is equal to turnaround time minus burst time. So 5 minus 5 equal to 0. 8 minus 3 equal to 5. 4 minus 1 is equal to 3. So the average time for shortest job first is 5.66 and 2.66. Shortest remaining time first. It is the preemptive version of shortest job first. So it is the preemptive scheduling algorithm. So it gives some priority to other processes. So at the time of 0, P1 process arrived. So it execute 1 millisecond, then remaining 4 milliseconds. Then at the time of 1, P2 executed 1 second. So remaining 2 milliseconds. And at the arrival time 2, P3 executed. So the remaining execution time is equal to 0. So now we consider lowest burst time. So compared to P1 and P2, P2 has lowest burst time. So next P2 executed. So 3 plus 2, 5. After that P1 executed. 5 plus 4, 9. So based on that, we calculate turnaround time and waiting time for shortest remaining time first, and also calculate the average times already I explained. Priority scheduling. Priority scheduling has both non-preemptive and preemptive versions. Non-preemptive scheduling means once a process starts execution, it runs until completion. Even if a higher priority process arrives, the current process isn't interrupted. These are the priority value of process P1, P2 and P3. The lowest number has the highest priority. So here process P2 has the highest priority. But here arrival time given. So at arrival time 0, process P1 executed 5 milliseconds because No process is waiting in the queue. Then it consider the priority. So here P2 has the highest priority. So it executed 3 milliseconds. So 5 plus 3 is equal to 8 milliseconds. Now P3 has the lowest priority. So it executed 1 milliseconds. 8 plus 1 is equal to 9. So the completion time of P1 5, completion time of P2 8, and completion time of P3 is 9. Now we calculate the turnaround time and waiting time. These are the values of average turnaround time and average waiting time of priority non-preemptive scheduling. Priority preemptive scheduling. Preemptive scheduling means the operating system can interrupt a currently running process if a higher priority process arrives. Here also, P2 has the highest priority, but arrival time given in this problem. So at arrival time 0, no process is waiting in the queue. So P1 executed 1 milliseconds, remaining 4 milliseconds. Then it considered the priority. Compare P1, P2 and P3. Here P2 has the highest priority. So P2 executed. So 1 plus 3 is equal to 4. Now remaining P1 and P3, we compare these two processes. P1 has the highest priority. So already 1 milliseconds P1 executed, remaining 4. So 4 plus 4, 8 milliseconds. Then P3 executed with execution time 1. So 8 plus 1 is equal to 9. So the completion time of P1 8, P2 4, P3 9. Now we calculate the turnaround time and waiting time. These are the values of average turnaround time and waiting time of priority preemptive scheduling. Finally, round robin scheduling. In this problem, they given the quantum value is equal to 4. So it is a preemptive scheduling. So all the processes equally executed at the time value given. So at the arrival time 0, P1 executed 4 milliseconds. Then P2 executed 3 milliseconds, so 7. Then P3 executed 1 milliseconds, so 8. Again, P1 has remaining 1 milliseconds, so it will execute at last. So now the completion time P1 9, completion time P2 7, completion time of P3 is equal to 8. Now we calculate the turnaround time and waiting time based on that formula. The average turnaround time and waiting time of round robin scheduling is 7 and 4. In this problem, shortest job remaining time first has the smallest average waiting time. Thank you.